So before I forget, I was actually reminded to say by other team members who are also visiting out here that we are hiring. We are hiring Postgres DBAs. We are hiring Postgres engineers. And we would love to talk with you if you guys are interested. I'm looking at Robert and others who it's like, what? So just kind of like a quick background. I actually, before I joined VMware, I used to work a lot in the performance area at Sun. I did work with various, the way I put it, as non-Oracle databases that included DB2, MySQL, Postgres, and a bunch of others that many people may not have heard about. And actually, I was part of the team that actually did I think it's still the only published benchmark with Postgres, which has gone through a full audit on using Spike App Server benchmark, which was run using Postgres and the Sun Glassfish server at that point of time. Anyway, so the purpose of my talk is actually to highlight more about DVDStore benchmark. How many of you have heard about DVDStore before? Okay, all right. How many of you have used it? With Postgres?
I think so.
Okay.
This was like 5-6 years ago at least.
I mean, there was no Postgres port at that point of time, so unless.
I thought Jan did something.
Okay. All right. So, and based on the people out here, how many of you actually use Java along with Postgres? Two?
Used to, but
Not anymore? PHP? Okay. Node.js? Ruby? Okay, good. All right, thanks. So basically, kind of a little background on the history. So DVDStore was actually created by two engineers in Dell, originally designed to identify or actually prove the Dell hardware systems using a realistically web-based workload. And as the name says, it's actually DVDStore. You actually go out there. The use cases that it actually handles is you go and link to like an Amazon kind of website, browse for DVDs, select the ones you buy, and then check it out. So that was the kind of purpose. But the other implementation detail that they actually wanted to do is like they want to use that same application and actually do it on multiple frameworks, because really, I mean, the purpose of this benchmark kit, this kit is to do performance testing for your environment that you're trying to use it for. And if you are, say, using Java with Postgres, you don't want to use a performance tool that is only stressing out Postgres. You really want to stress out something that's the complete stack that's representative of your application. So that was kind of like the background and like what led to this benchmark kit in the first place. It consists of a few of the pieces that we'll go over during the next few slides. Anyway, going back to why you want to do performance benchmark. Like how many of you are actually doing performance benchmarks before deploying anything on production? It's like one guy, two guys. Yeah. All right. So I mean that's kind of the thing. So here's the thing. Like I've run into this frequently, right? People take a published benchmark and say my stuff can do this much, and then they build something on top of it using those technologies, put it into production, expecting everything to work, and the first day it crashes because it cannot sustain the load. So one of the things I always like to say is the advertisements are actually that. The advertised performance are really advertisements for the individual products. What you really need to do is like see how that actually applies to your environment. The common thing I say is like, your performance needs can be anything other than the advertised performance. And it may be that you may actually need performance much less than that, but you may not even though that advertised thing says like I can do 4 million transactions per second, you apply it in your environment and it just crashes down. So always, I would say, always do a small test before you actually deploy anything in production. And it could be amazing what you learn from that experience. I mean, we have been doing this for a while, like even at VMware. Before we ship out products, we actually send it through what we call as the performance regression test. And it's amazing, like, you would have, like, even if you like, you initially start with like 3 tests, and then there would be always one more benchmark which can really break you down. So once as you do more and more of these benchmarks, you will learn a lot of interesting things over the course of that. But the gist is, like, never rely on just the performance numbers that somebody tells you, because it can only apply to the environment and the server setup that they had when they published that benchmark. And I'll tell you, every deployment, every configuration out there is different. As soon as you use a new kernel build, it's different. I mean, sometimes it can get to that level. And that's kind of like the nature of like DVDStore. Like, if you want to do this kind of setups and test it out easily, there is not, you need like a benchmark toolkit, which is kind of like easy to set it up, do a quick run, get a sanity number and test in place, and say that helps you build the confidence. Like, no, my setup is working right. And sometimes, like, in the classic Postgres world, people use PGBench a lot. And that's kind of the idea, right? You have done some sanity testing with PGBench. You know your database is up and working correctly, as you would expect, and then now we can do different things. Typically, I would say, like, sometimes database is not the only application running out there. You would have like a Java server. You could have a PHP talking to it. So you might want to actually do a performance test based on that whole stack, and when you do a deployment and new setups. Sorry, I think there are a few things being cutting off, but it's not much I can do. So anyway, going back, what DVDStore does is it's basically, it's kind of representative of like a mini Amazon kind of thing. You go to a website, log in, browse for DVDs, select the ones that you want to buy, and actually check them out. And it's kind of like pretty simple. The original port that was done with DVDStore was SQL Server, because it was actually developed for Dell systems using Windows, using SQL Server and the stack at that point of time. And gradually it grew to include like support for other databases like MySQL, Oracle, DB2. And about, I think, late last year, we added a port on the official download for Postgres that you could do out of the box with it. And most of the time, you would see like some of the implementation that we selected for Postgres was not all of the ones that DVDStore supports, but the one that is kind of like more common with Postgres. So we kind of like selected the Java JDBC model. We did the PHP MySQL type of LAMP step kind of model. So it uses basically web server PHP and Postgres. We actually purposely did not do any ASP.NET. How many of you actually use .NET type of applications with Postgres? It's amazing, like every conference that I ask, I don't get anybody who does that. And unless I see one person, nobody's going to work on that port. Oh, really? Okay.
I know a couple people that actually do that, but I don't know if I've ever met anyone since I left there.
And it's amazing, like, I've been talking about this for a while, and I always ask this, like, who uses .NET with Postgres, and I haven't seen anybody yet. So it's like, thank God I'm not spending my time on this port. And the last thing is, like, one of the other things that we are seeing a lot is, like, you now seem to have this software as a service model. So a lot of the people, the way they want to do things is like, they don't want to go directly to do SQL queries against the database and do everything on the client side. They actually write up kind of like a business logic in some place that you may actually want to do in stored procedures and just invoke those stored procedure calls from your applications. NPGSQL is actually the .NET driver for Postgres. Unfortunately, DVDStore was actually designed for SQL Server, so it actually used the .NET framework. And I actually had a hard time trying to rewrite many of those things to work with that framework. Anyway, so here's the kind of like the schema. The schema is pretty simple. It has like 8 tables. It represents customers, products, categories of DVD. It kind of like has an order entry system, so it has like an order lines. It allows you to keep a history of how many previous orders you did, and it basically also has this MRP kind of system where if your inventory goes out, you need to replenish it by getting new DVDs for those titles. So it kind of like, that's how the schema was based on. And the transactions, if you try to dig into the detail, there is actually a breakdown, like what it allows you to do. It allows you to log in as customer. It allows you to create like new customers if you want to do that. And basically, the way it actually maps out from user view, it goes from this user scenarios to this DB transaction. So these are kind of like the main transactions out there. And instead of going through each of the details on the slide, I'm just going to show you a demo that I have on that port. So this is kind of like one of the implementation done with DVDStore. It has this new customer button. If you already are a customer, you could actually just log in. It shows you your previous purchase that you did. You could start shopping. You could start searching for DVDs as you like. I mean, it was a pretty simple thing, but it's sleek and it works. You could select the apps that you want to buy or the titles, and then you could actually check out. And then you could actually, this is kind of like your order confirmation screen, and you do a purchase. And it says, it charges to a random credit card somewhere. And basically, it says your order is completed. So it kind of like tries to emulate a web-based workload. It's kind of interesting. If you actually go through this thing, you would see that the purchase is the real write transaction. Everything else seems to be more like browsing scenarios, which is true in many of the web-based workloads. So what really happens is like, there are quotes that I've heard from people, like 95 to 99% of the transactions that happens on a database for web-based workloads are reads, and the rest of them are writes when you actually do something like execute an order transaction or buy a plane ticket or or do those kind of things. So this is how the app actually applies to real world, like in what scenario you think if it fits into. So this actually applies to more like a web-based workload from that perspective, which would be roughly about 90% type of reads, and the writes are happening out there in less than 10%. Okay, so going back. So what we did originally was we ported to Postgres. When we first ported the Postgres, the thing we found was like porting the schemas was damn easy. Actually, it was like literally not much you had to do. But when we started doing the initial test, we figured out that compared to every other database, it was actually behaving very bad. And eventually, we ran when we dug deeper into that, we found like some of the things that they do on other databases, the way you would re-implement them on Postgres was like they were using a lot of text searches to search for titles, categories, and other things, and they were just using the like thing out there. So that's one of the things that when we did the Postgres port, we changed that to use text search feature of Postgres. And as soon as we did that, it kind of like brought Postgres back to the level of what you would see like in equivalent to other databases. Like in most of the other databases, when you do text-based search, you would use something specific to that platform. So those are kind of like the small things that, again, it's good to know as a developer of a stack that when you're doing like your data selections, make sure you're using the right DB features for that. And text search was one of the things that we actually ended up using for this particular one. The other thing is like compared to other databases, the things that were different, the language used for the stored procedures that was used was PGSQL. The implementation for PHP actually had dependencies, so it was using the PHP PGSQL module. And there are some issues with that too. The Java version was actually using the classic JDBC driver for Postgres. And there was actually a driver implementation that needs to talk directly to do the services kind of implementation that was done using the .NET framework. So, I mean, the next few slides, I want to actually go on how you actually set it up before we actually do the demos on it. So, the steps that I have are kind of like more detailed. Like if you want to do your own hands-on approach for DVD store, you need to get a lot of things from different places. So for this particular set of instructions, I had used CentOS as the OS. I mean, believe me, I've never used CentOS before. The ones that I used previously was SUSE, and it was a new experience for me, and I actually enjoyed it. Setting up the database was quite easy for me since I have done that a lot. It was kind of like no-brainer for me. Setting up the DVD store, there were some issues if you go right from the download website. The searching and downloading are easy, but over the course of the thing is like, so other people don't spend the same amount of time I did to make it work. Here's a quick list of things that you want to fix on it. I'm actually working with the author of this benchmark kit to actually have these fixes right into the code itself, so it actually works out of the box the next time when they do a refresh. So what happened is there were 2 engineers at Dell, and later on one of them actually joined VMware. So right now VMware has as one of the guys in VMware and the other guy is in Dell. The thing is hosted by Dell, because if I actually go back to the website, it says linux.dell.com. Obviously, we cannot write out there directly. And the thing is, like, the interesting thing is, like, what VMware is actually doing is it actually uses this. If you have ever used, there is another benchmark called VMmark, which VMware actually uses to stress out virtual machines a lot, and which is part of their official benchmark. That one also uses DVDStore within that. So it is being used heavily in VMware. And what we are also doing a lot with Postgres at VMware is to use DVDStore to do scalability studies and understand the bottlenecks on that respect.
How do you simulate a load from a client's perspective?
I'll go over that, yeah. So anyway, these are kind of like the quick fixes. Once you do this, you shouldn't have any other problems related to the operations of a DVD store with Postgres itself. To kind of go to the details, like some of the stuff is like, even though they do seem to have binaries pre-compiled for you on Linux, it doesn't really work out of box, say for CentOS. So I'm kind of like, for the completeness of documentation, I'm including all the steps like that were done to actually get those benchmarks working. There is actually a script out there. Like, the first thing you do after you set up a database is you have a database with no data in it. So you want to actually get data to be pre-populated for a benchmark. There is actually a script called install DVDStore, which helps you generate the data. So going back to the previous slides that you compiled, the Perl script is basically a wrapper around them and say, tell me the data size you want to generate, and it goes through all those data generator files and creates the right data for each individual tables to be loaded. So for the example I had used was the 100 meg template out there. In the past, I've done till like 1 terabyte with this benchmark. It performs smoothly. I haven't seen any problems with the data generation piece all the way out there. Setting up the database on Postgres, here are the quick steps. What happens in a benchmark scenario is like they try to highlight a lot of things for multiple benchmarks. So sometimes I think like this kind of steps actually help you to do things a lot quicker, because not everything can be covered in the documentation in the benchmark kit also. So like creating the database and kind of the classic thing is most people know that, but people who have never used Postgres still would need guidelines. So I have included them in the slides. Few of the other things is like, when you install a lot of things on CentOS, there are a lot of default firewalls running, so make sure you turn them off. Use the Sun JDK. I'm still a big fan of Sun Java, so I always use that one. and set up the Tomcat server as needed. Now, when you want to make the benchmark work with Postgres, you don't get all the files that you need out of the box. You still need to get the JDBC driver that you want to use for your Java setup. So say, for example, these steps are primarily for Java setup. If the Java setup provides you with the app that does the DVD store, Postgres gives you the database server. The missing connection link out there is the JDBC driver that you need to put in your app. It's pretty simple. I'm just including that for completeness. So if you want to follow the steps, if you want to repeat the benchmark, you could do that. There are also some steps, like if you don't have the app server on the same system as the DB server, you need to edit a few files to make sure you're pointing to the right DB server. So these are kind of like the setup instructions. I'm going to go quickly over them. So if there are questions, ping me on that one. For the PHP server, same thing. It's actually easier to install Apache HTTP server, install the PHP Postgres modules to set it up. There were one change that I actually had to do to make sure that the PHP module is PHP Postgres module is enabled in the web server. So these are kind of like, for the completeness, because you'll find that most of the steps are not included in the benchmark kit because they would expect you to know how to do those setups on your own. So that said, the same thing, like once you have a PHP thing in the Postgres directory, so we could actually do a quick online out there on how it sees up. So when you download Untitled things, you actually get like a set of directories. There is a PostgreSQL DS2 directory, which is kind of like the Postgres-specific things. If you download it for other databases, they would go into their each individual database. Within PostgreSQL2 directory, there is in the web base is where the individual implementations for Postgres resides. So if you want to use the JSP with Java, then you actually look at the the web directory, and you look at the JSP directory out there. This is where you get the app for your DVD store. Same with PHP and other things. Okay. When you run the schema file, it actually does that for you automatically. So for the web-based setup, you don't have to do much, but most of the setup instructions are primarily for PHP and Java. I don't expect people to do all of those implementations, so you actually take the framework that you work most with and use that as your reference implementation that you want to use for benchmarks. Anyway, so coming back to the driver side of it, there is actually two kinds of drivers that are available in DVDStore to drive load. One is actually called the web driver, which actually works on the web UI. And it primarily it is meant for the web UI that you use for Java or PHP. And there is a second driver, which is very Postgres specific, which is the stored procedure type of service called directly from a program. And that one goes directly, it invokes stored procedures. So the whole business UI logic of whatever you do in PHP and Java is now actually implemented in stored procedures running directly on the database. So that's kind of the setup out there. The problem with the driver right now is it's written in C#, so it requires a .NET environment to run. So on Linux, the only way I could make it work was to use Mono framework on Linux. So once I use the Mono framework, it is relatively easier to use it, but the hard thing for me was actually getting a Mono that works with the Linux distribution. So I have pointed out to the one that I actually eventually found for CentOS. So you don't have to recompile it on your own. You could just download it from that particular repository, and that seems to work. Again, what I have found is like the benchmark kit actually gives you binaries for the .NET framework. which unfortunately, if you try to run it on Mono, doesn't work. So you need to recompile those drivers using the framework that you download. So it's kind of like the steps that I have on the slide. It helps you to do that. And then there is another Perl script which actually helps you to set up the configuration for the run. Now, this is kind of interesting because basically this is the whole list of parameters that you drive to the database. If you go like the target is basically either your web UI or the Postgres server that you're trying to connect to directly. The number of thread basically is the number of clients you want to hit on the data on that particular infrastructure. The ramp rate is like at what rates it starts adding more and more users. So for example, if you have 10 and you say the ramp time is 10, it basically spawns off one user every second till it gets to 10 users at the end. So it's kind of like some sort of, instead of trying to run, spin off 10 users at the same time. This gets actually more useful when you run the test with, say, thousands of users. You don't want to spin off thousands of users at the same time. You could get into trouble. What you want to do is actually use the ramp time to do those kind of like a slow ramp over, say, a minute or so to ramp if you want to go to like that high levels. The DB size is basically used for the load driver to know, like, what's my scope of the database that I'm going after, so it can actually try to go after the whole data set. I've actually used this innovatively. You could use a bigger data set size and you restrict that to a smaller working set, and that actually helps you to say, like, kind of emulate what if 80% of my data is going to be static and only there will be 20% of active data set working on that. And that would actually help you to kind of like do some analysis which would be more realistic to your world if that's the case. In the benchmark world that I live, I try to go after all data so it's uniform. So you could really highlight, go beyond the memory of your systems to prove that point. Then there are other parameters that actually does the detailed cutting, which I normally don't change a lot. Sometimes I do change the percentage new customers, like how many new customers do you want to create during the process. And most of that, the only one I believe I sometimes change is if I'm putting my app into a separate app, the app names are different. There would be a different virtual directory name. So that's probably something that I change, and the PHP type. If I'm going against PHP, it's PHP. If it's JSP, it's JSP. I haven't seen much difference either way you do it, because it has no clue about, it only knows about the UI or the stored procedure version. It doesn't know anything else about PHP or JSP because it goes against the UI. As long as the UI are consistent, you can have any framework behind that, so you can drive load against it. This is speaking HTTP. Yep. So there are two modes of this driver. So the web driver speaks HTTP, and the DB driver actually speaks the Postgres wire protocol to talk to the stored procedures. So the real thing that we do is we actually have two versions of driver. They use the same config files. So the config file doesn't change, but the executable that you run changes. So in this scenario, the executable that I'm creating out here is the web driver, which speaks HTTP and goes against the UI. And then there is another driver which goes against the Postgres server directly, and that needs to be compiled. There is actually a different program that you compile which speaks the Postgres wire protocol using PostgreSQL to talk to Postgres and execute that benchmark. So based on that, let's go to some demos that I want to do on that. So we've gone through the web UI-based setup, and basically I did pre-compile those steps. And I have the driver.config file, and I created the web driver based on that compilation steps. And if I look at my driver.config, the whole setup that I have for the demo is actually running on a virtual machine on my laptop. So it is all running on this particular MacBook. So I'm going to keep it simple enough that I have 2 threads going against it. I have 2 instances running. One is a PHP web server, which runs on the port 80. And I have another instance running the Java Tomcat-based server talking to Postgres at port 8080. So we'll take a look at that and how it kind of like behaves when you run those things. So the way to run the benchmark then kit is actually pretty simple. Like once we could actually go a step further. Like if you want to, when you're setting up the database. So in this particular case, I actually created a data set of 100 meg. If you look at the actual text files that it generates, it's about 68 meg. If you try to do, you could load it up.
So this is CentOS running under VMware, or is this a?
This is VMware Fusion, yes.
So this is running under Fusion.
It's running under Fusion right now. So there is this script called PostgreSQL ds2 create all.sh, which has all the schemas, and it loads up all the data from the data generator, the files generated by the data generator. So like this one is like loading up like 100 meg of data from a sample data set that I created. So the script was kind of like rewritten a few times so that it's very intuitive. You could run it over and over again. So you could have like every point of time you want to refresh the data, you just run the script. It refreshes all the data back, analyzes the schema, and you should be all set. And then you could go back to your driver program if the PHP and everything is all set. So like this is my something that this is the DVDStore homepage, and I'm actually going right against that. Like if I look at my driver.config, this one is going to the port 8080, which is the Java version of the implementation. And the step to run the script is if I can type well. Config_file. So what this particular does, it uses the HTTP protocol to go after the web UI. And the web UI, if you look at the web UI implementations, they're all defined the same. So it actually uses that knowledge, and it does like a load generator simulating, like in this particular test, it's simulating 2 runs. Now, what you would see if you want to read this, this is kind of like the metric that it kind of pops up, which is called the orders per minute. So like I mentioned, like the way the app is designed is you browse the catalogs, find the titles you are interested to buy, and you buy them. When you order them, that's one order for a user. So the way the benchmark works is the metrics that it uses to measure all those things are called, it's measuring all the orders that you can generate on this particular setup. So it generates a metric called orders per minute. And in this particular setup that I have on my workstation, you see that it's doing like about 277 orders per minute on the setup that I use. So I'm running pgtop on the other end. I can see, like, if you want to look at the real transactions happening on the database is, this may not be exactly correct. I need to check if it's reporting the true value or not. But it's showing roughly about 256 transactions per second, and it's showing that you still have some power that you can run off on the system. So it's still not saturated. So you could still try bumping up that particular one. So I'm not going to do that one on my laptop. You could do that on your server. But just to show that you could actually run it against, say, the PHP version, it's not much you want to change, but just for completeness, I do.
So this is VMware running on your Mac?
Yes, this is running on my Mac. It's not a free version, though. So this is now going against the PHP version with one driver. So like, and sometimes you would see that depending on the framework you use, you see different performance characteristics. And most of them, it's based on like how you tune those individual stacks for your needs. So like in this particular PHP case, in the other case, I've never tuned the Java server, but in this case, the web server and the PHP was pre-tuned. So now I could actually do like, say, 3,000 orders per minute. Just because I'm running it out on my laptop, I have disabled syncs and other things. So that could actually explain you why I'm getting such a high number. But that makes it easier to kind of like demonstrate the power. So the other cool thing is like, you could take a look at that and see like, at what point does it make sense? Like, are you getting the things like the numbers by itself is only a clue to what this particular benchmark represents for your system. This is in no way relation to like, this is the best number I have and I want to get more. That's not the philosophy. It's like, how do you use this to do a standardized testing on your setups that you have deployed? And if you take it to a performance benchmark world, people would go way higher numbers. But in some respect, it's same about pgbench, right? I mean, pgbench is a tool to help you identify the setup for your particular server configuration that you have at that point of time. And the same way is the DVD toolkit to help you set up with the particular framework that you're using out there. So it's interesting, like you are, with the PHP version, you could do like about 3,500 orders per minute. Yeah, I would say Postgres is good. You could do that on your laptop, right? Similar things, if you go back to the so this is the other version that goes directly against the stored procedures. And for this particular version, I actually had to use NPG-SQL, and I had some issues like which version of NPG-SQL. I actually had to use a particular version 2.0.11 to make this particular one, to make this work right now. On the latest version, there were some casting issues. I still have to figure out how to resolve them. But on the same note, so there is another driver config out here for with the same 2 thread nodes going against the same thing on the database. And if I run this test, so this is like a different framework. This one is actually using stored procedures as a way of doing business logic directly on the database, which and those stored procedures are the one that actually modifies the data in the database. So it's kind of interesting, right? You can now do 12,000 orders per minute. I mean, remember, like different frameworks actually gives you different benefits. Sometimes what I'm highlighting out here is like there are ways to optimize things on your particular framework. There could be ways which may be slow for your particular framework of choice, but you could actually do some identified migrations or pushing them to the database level to actually reduce the bottlenecks out there. So for example, like this particular one, just because everything is running on the database, there is not much round trip going between the clients and the database. So everything runs in those same backend processes. And then you can actually see that the DBs can actually handle them pretty well. So I mean, this was kind of like the demo that I did on my laptop. What we have also done is we have run it on a bigger systems, and there were some problems that we actually came across. So I want to talk about them, and this could be actually useful. Maybe I'll get some hints on how other people actually fix those kind of issues. Like I showed, Java out of the box is not tuned for such kind of workloads. So definitely you need to spend a lot of time in tuning your Java app server. And most people, if you just use Java app server out of the box, you would actually see this kind of performance issues. You want to bump up your heap size, tune your garbage collector and everything well for that needs, and also tune your JDBC connections that are going against the database. It's not something that you just install and it should work well to that high level. PHP Postgres implementation. Actually, I kind of encountered this, which was not there on MySQL, but it was specific to the PHP Postgres. Every SQL that it executes, it results in a new database connection to Postgres. And that has been one of the problems I found. Now, this doesn't have a lot of problems if the database is running on the same system. But if you have the database on a different server and you're doing network calls, the benchmark would actually quickly run out of sockets to connect to the database, because it spins through those connections so fast. Most of the sockets are now waiting in a timeout period that you cannot reuse them. Even if you tune them to go to the highest level, you will eventually reach it if the workload is big enough. So the workaround that I eventually found for it was to actually use PG Bouncer on the system where you have your PHP app, such that your application connects to PG Bouncer using the local sockets, and then your PG Bouncer does connection pulling to the backend database. And that's probably one way. I don't know how other people with PHP actually implement this kind of things.
Yeah, I mean, it just seems really bizarre. Like, you'd have to go out of your way to make that happen.
Yes.
The one connection for SQL command, because it's not the way that it would normally work.
It is how it works out of the box.
I mean, say for this, maybe that's the case. I'm saying when you write a PHP app, right, it should be generally be one connection per page that you're executing. So you could have 10 different queries in that page, and they would all use the same connection.
Why? But every page is a connection, right?
Yeah, so that would be the case.
So that's the problem this guy has. Like, when you go to different pages, every page actually has a connection. And then if you're going through this benchmark mode, then you are spinning off those connections pretty fast, that it runs out of that's the magic number, yes. You could bump them up. You can bump them up. You could lower the timeout to like the list that 5 seconds. Like, I think the default is 60 seconds.
I don't know how difficult it would be. You have to look at code, but I mean, if you have one app that you're connecting from the one database, I mean, you could turn on persistent connections in PHP.
So apparently that used to be the case, and they pulled it out because it wasn't working well. So I read through those notes.
I would say normally I wouldn't recommend that for production.
You mean persistent across page, for instance? Like, it's persistent in a page or persistent across a page?
Across the page.
Yeah, so it's like pooling.
But it's like pooling, but not good. But would stop connection recycling.
Right. So I mean, those are the issues. Like, people using PHP MySQL doesn't seem to have, they seem to have this persistent connection pooling out there, which wasn't the case. But anyway, I mean, the thing is like, that's the thing. Had I not been doing this kind of test, I would have not identified this problem before deploying to production. That's why you need to do performance test.
Have you ever run this test through a load balancer, where the load balancer is running on VMware, and it does the natting so you can get more than 65,000 connections? Then you can do tricks like that. The load balancers handle far more connections.
Yes, you could do tricks like that, but like, to me that's like buying more hardware for a software bug, right?
I'm saying you can simulate, the bottleneck is usually around 32,000.
Yeah, but what my point is exactly by using PG Bouncer in this scenario, I don't have to do anything else, because what I'm doing is like I'm getting all those PHP calls go to a local PG Bouncer, not using the sockets, and then this PG bouncer can do a great connection pooling to the backend. And now I can I can work around that problem. But the gist is, like, had you not been doing this kind of test, it would be actually you would be finding these problems in production. And sometimes, like, that's what I like to say is, like, performance benchmarks are kind of like different for different people. But if you actually take the approach of doing it across your whole stack, you will actually run into problems that most people may not talk about a lot. And you could actually you could do some proactive work so that when you go to production, you don't have those kind of issues. The interesting thing also from this I want to mention is, like, from all the tests I've done, stored procedure seems to be working real better than any other implementations. And the reason is very simple for that. The whole thing is running in the backend database itself. So it doesn't have to do any round trips to get data, process it, and go back and stuff like that.
And you see another speed improvement.
Yes.
Yeah, 'cause I've actually always wondered about that. You don't use a lot of stored procedures, but
No, sometimes it's a magnitude difference. So the way most application works is they have this business logic out here, right? So you do this business logic. You make a call to the database, come back, do more logic calls, and then do a call again, get the next set, do more calls. What is happening is you're now serializing everything. So there is not much efficiency built into that model. What the right model is, you get all the data that you need together and then run the business logic in one go and then push it back in. But if you look at how most applications are written, they pull the data only when they need it, right? And when they need it, they cannot do anything else. So what do? They wait for the data to come back. So that's kind of like one of those efficiency programming things. Like most ORMs and other things may actually try to do that underneath that. I don't know. But this various implementations clearly bring that forth, that keeping your application server and the database way away from each other would lead to latency problems that you need to be aware of. And kind of like a final note, the database transactions are not really kind of like mapping out correctly in my demo. But when I did on the real server, there was a clear kind of like mappings. Roughly about every order per order is roughly about 6 to 7 transactions happening on the database. Like if you look at, there is a login process, there is a browsing process, there use case before you go to the order. So there are like about 7 steps you need to do. So that represents 7 transactions on the database for every order. So those kind of metrics actually help you. Like from your business perspective, orders is what you really care about. How does that map to database transactions? Now, can your database handle that load? And then suddenly, once you have all those things working out, you actually can get a good feel about how your system can react in a different physical setup or server setup that you may have. So those things then can be used to plug into, say, capacity planning for your production setups.
when you've done this test, but I guess the question is the Postgres security model the trust model where there's no password, or is it?
No, there is a password involved. So yes. So there is authentication that happens. When you create the schema, it uses a DS2 web user, which has an kind of like a super user model. All the web-based thing that happens, they use a web-based, they use a user ID of web, which doesn't have any authority to change or create any more tables and stuff like that. So it has the full authentication model built in. So when I'm running it on my local setup right now, I have trust. So it doesn't really do that. But as soon as you go onto the network things, typically the setups that we would do, it would be the at the least verify the password.
I've never actually done any serious benchmarking on that. We always run everything in trust.
Yeah, I haven't seen significant problems with this authentication modules yet on all the tests. So the other thing is, like, once you go across, say, 4 CPUs into the 8 CPU and the 16 CPU territory, there is another problem that actually crops up, which is kind of like inherent in the data in the design of that. And that's something that I'm still working with the with the authors to see how do you fix this. Say, for example, it's classic thing. You start small and then you grow big. When you grow big, you could have millions of customers. When you have millions of customers, you could have, say, 1,000 to 2,000 users hitting you simultaneously. At that point of time, there is another problem that pops up is your production inventory, the product inventory gets depleted pretty fast. So the restock actually has to do more work to keep up with the inventory in the back end. And the way it's currently implemented, that when it does the restocking, it only adds 1 or 2 products. So when you run a huge workload, you get to a period that you have a great performance, and then you hit that everybody is like the inventory is depleted, and they are constantly doing restocking out there. So there are a few changes that we are suggesting in this model, which would kind of like do restocking at a much higher level, which would bring back the peak performance to be more kind of like uniform out there, which is more representative. Because when you're doing restocking of orders, you don't order only 2 or 3. You really take it back to the old levels that you had. So there are some more changes, and you typically wouldn't identify them, say, on 8 CPU cases or less, because there wasn't much things to be, there's not enough load that could actually deplete that quicker. But we see that more and more on those higher end testings. This is running auto vacuum, yes. So you still see the classic performance when you run it over a period of time. You see peaks that I've seen is like 110,000 orders per minute. For some time, then it would go down a bit, then it would come back up, go down a bit, back up, and those kind of standard variations. And that's probably the other area that we try to focus a lot is like, how do we get rid of these variations? Because ideally, the last thing a production analyst has is they don't want to see variations. They like stability in their environments. When you see variations that you cannot explain, then you look stupid in front of your executives, right? So you want to be able to explain them what exactly is happening when your performance actually goes down a little bit. I would say, auto vacuum is running, checkpoint is running, that's why. And they would say, fix it. It's like, I can't. But anyway, so once you start maintaining those kind of history, you would see that kind of behavior. And when you do this kind of test in your own setups, you would actually identify things which are very specific to your environment. It could be a particular network card that you use has a very special characteristics which actually impacts you. Sometimes those are very hard to find. But if you keep like this historical data for your setups, you can now actually refer back. Like you change something in your setup and you see a different performance. Now you can compare against the old setup you had and see, and then like what had really changed between the configurations. And that could actually help you keep track of which things work well in your environment. So so the gist of that is do those tests regularly and keep history, because the history is what you would look for when things go wrong. So with that, the future that we see right now is basically how do we convert the driver from, say, .NET to to Java or Python so more people can run it. And the other thing we are trying to look at is like should we implement this benchmark for, say, Node.js or Ruby? Is anybody interested or implementations in that? All right, OK. Python? All right, sounds good. Mm-hmm. Yep. So I'll put up an open source request and hope one of you guys work on it. All right, thank you very much.